All right. Hello, students. It is Mr. Rich, and this is our math Q&A for our last day of November. And hopefully you all can hear me out there. What we're going to do tonight is I'm going to do a little bit of a talk on SAT. We have an SAT test coming up this Saturday. If you're prepping for the SAT, you certainly know that. This Saturday, December 6th, is another SAT. So I wanted to talk to you. I got 5 things I want to talk about with regard to the SAT, things that maybe you aren't told about the SAT by the College Board or by maybe counselors. Probably your tutors would be telling you some of these things. I certainly tell these things to the people that I coach on the SAT math section. So the first thing that I wanted to talk to you about is that the SAT reuses the same patterns in their tests. And what I mean by that is that the test is somewhat is predictable, that they will use the same question styles over and over again. You'll see the same kinds of patterns, such as missing constants in the equations. You will see very similar growth decay equations, quadratics that cover vertex form and standard form in word problems. You'll see function notation traps typically, but the so basically the content really isn't the curveball, it's the presentation. It's the way that they're coming up with questions. They come up with questions that you can expect, that you know the underlying content, but they're giving it to you in a way that seems unfamiliar, that like you don't recognize what you're supposed to do. Now you may say, well, that seems like that's not a pattern. Well, it is a pattern, right? Because you can learn some of the ways that they ask the questions in unique ways, so that when you're presented with a quote unquote new problem by the SAT, by the College Board, one that no one has seen before, you might recognize it similar to another one that has a similar kind of a pattern to solving it. So the point is that since they do reuse the same patterns on their problems, your path to success is going to be doing lots and lots of practice over and over of SAT style questions. Once you understand the underlying content and you don't have any gaps from your algebra 2 or from your geometry, then it's a matter to get your highest potential. It's a matter of doing practice problems on SAT style questions. All right, then the second one that I wanted to mention is that you don't typically hear from the College Board or from academic counselors is that the SAT does go beyond Algebra 2. Technically, officially, they test through Algebra 2. But really, the higher scores are ones that are taking higher level math because they are going deeper into the concepts that are tested. And there are some concepts on the SAT that if you haven't taken AP stats, you may not recognize, such as margin of error problems or some of the sampling theory problems. So AP Stats is definitely going to help you. If you're taking pre-calc honors or AP pre-calc, that's going to help you as well get some of those trigonometry questions right at a higher rate. So definitely, if you're trying to get your highest level math score on the SAT, it does help when you're a junior to be taking AP pre-calc or to be taking college algebra, something, or even AP Stats. But definitely you want to, if you're a freshman or sophomore, you definitely want to be pushing yourself to watch, or not watch, but to be taking those higher level math classes as you can. It is going to pay off on a higher, with a higher SAT score. Okay. Now the next thing that I wanted to mention that you probably have heard is that the SAT is adaptive. I'm not saying that that's not something that they tell you, but the math section, now that they've gone digital in the SAT, just like the English section, it is adaptive. So you are going to be measured on how you perform on module number 1. If you miss, and we don't know what the exact number is, I certainly don't know what it is, but it seems that it's probably around 4 or 5 questions on that first module. And they may even scale it according to which ones you miss. But if you miss a smaller number of problems on module 1, then they will assess that you are a student who could be testing into the 600s. They will give you a harder module 2. If you perform poorly on module 1, then they're going to say, okay, we're going to have to back off a little bit. We'll give the student an easier module 2. If you do get put into that easier module 2, then you really are capped at probably high 500s, low 600s, no matter how well you do on module number 2. So you want to be getting into that hard module 2 by doing very well on that earlier module, module 1. Okay, so that is that one I think most people have heard before, but it definitely is true. But I will say this: you definitely want to be in the hard module, because if you get into the harder module and you still, will say, bomb that second module and miss more than half of those, you're still going to be have secured yourself into at least the low 600s from what I can tell and from what I have seen. Now, a little bit about Desmos. The fourth thing that I wanted to mention is that Desmos isn't just simply a tool that you could use that's just automatically, if you know about it and you do a little bit of practice and know how to use it, that you're going to boost your score 50 or 100 points. It just doesn't work that way. Desmos requires you to really understand the underlying concepts of algebra, and requires you to be thinking graphically, right? If you just read a problem and think you're going to run off to Desmos and graph it and then get your solution, you're really kind of fooling yourself. You have to get enough practice so that when you read a problem, you're thinking about how this problem relates to a graph of the equations maybe that you're looking at, and what you would go look at on the graph to get the answer. For instance, if it's a equation in one variable that you're trying to solve, and you don't want to do the algebra, but you want Desmos to give you the value of x that would solve the equation, what I tell my students to do is to graph the left-hand side of that equation, graph the right-hand side of the equation as two separate equations, and then look to see where they intersect one another. So wherever they intersect, the x coordinate there is going to be the solution. If there's more than one solution, you'll see more than one intersection point. And I definitely tell my students to do that, especially with functions like radical equations, because you can get extraneous solutions. So you want to graph the left and right hand side, and the graphs will not lie. If they are intersecting, that's going to be the place where there is a solution. But what you really want to do, though, is if you're really trying to use Desmos to its optimal capacity, what you want to do is, I recommend watching some videos on YouTube of people working SAT style problems with Desmos and showing you the techniques that you would use for different types of problems. And then once you've done that, then you go and do some practice with SAT style questions. Because the highest scores I have found, when they read a really complicated problem, they are going to be thinking, how would I do this in algebra? how would I do it in Desmos? Which is the best method for me? Which, and by best, I would mean fastest combined with most accurate. And so you have to make that assessment as you're working yourself through the test. I tend to try to do more algebra, and then if I have time left over at the end of the test, use Desmos to go back and then check those answers by making a graph. Okay, so, but it does require you to put in a lot of effort to know how to use Desmos with different types of SAT questions. All right, last one that I wanted to mention is that the SAT test rewards strategy, both before the test and during the test. So you want to have some strategy as to how you're going to prep yourself. And that could include tutors. It could include YouTube videos. It's going to include lots and lots of practice and using and learning how to use Desmos to solve some of the trickier problems. All of those go hand in hand. I also tell my students, don't be afraid to use ChatGPT if you're trying to figure out different ways to solve problems. You can copy and paste an SAT style question into ChatGPT and ask it a question like, how would I solve this in Desmos? Or could you show me 2 different solutions to this problem? And I have found that ChatGPT does a very good job overall in coming up with solutions. So it's about 80% of the time I think it does a good job. So it can be used as a tool, and you can interact with it like you would maybe a coach or a tutor. All right, now I did have one bonus tip, and that is this: that when you get your SAT math score, you'll see that there are 4 domains that they will give you a score on. They'll give you a bar chart that's got 7 bars, and they'll color in how many bars you got to indicate relatively how well you did on those domains compared to the others. That really doesn't help much. Most of the time, students may be 2 bars short on one domain, 1 bar short on another, but it doesn't tell you exactly what types of problems you need to go practice within that domain. Right? Those 4 domains that I'm talking about are algebra, advanced math, geometry and trigonometry, and problem solving and data analysis. Those are the 4 domains. And so really the only way to know where you need to focus your efforts is when you do a practice test in the Blue Book app, is look at what questions you missed and then use maybe a third-party prep package to really zero in on those kinds of problems similar to the ones that you missed on the practice test. I use College Panda in coaching my students. That's mostly what I use. There's some other ones that I use, but College Panda has about 28 different chapters and subtopics that you can drill into, and their questions are very closely matched to what you're going to see on test day. So I highly, highly recommend College Panda. But don't think that the domain scores are going to really give you a pathway to getting where you want to be on your SAT math. Okay, so what we're going to do now is, now that we've finished that, we're going to transition into me doing some homework practice problems. And if you've got a question for me, I'm going to put my email address down here. I think I've got it on here somewhere. Yep, we're going to put it right there. So that's me at askmrrich@gmail.com. If you're one of my students, be sure to give me your name in your email, and I will put you definitely at the front of the list. So let me, I do have some problems that have already come in, and some of them are SAT questions. Some of them are calculus and AP pre-calc. So let me get that set up here. And I'm going to share my screen here in just a minute. And we will get to it. So again, if you are watching live and you want to send me an email, you've got the email right there scrolling across the screen. And here's the first questions. The first one actually is a statistics question that came in. So let me share this. And I think we have got it. And let's do it here. See if we can make the magic happen. And Christina, if you're on here, you might be able to help me do that. I think we got it here. There we go. Yeah. So we'll put this over here, and then we'll come over to we'll move me out of the way if we need to use the calculator. I think we will on this one. So here's the first question for tonight that came in, and this says that Amarillo Slim, a professional dart player, has an 80% chance of hitting the bullseye on a dartboard with any throw. Suppose that he throws 10 darts one at a time at the dartboard. So these are what we call Bernoulli trials, right? These are a random event where each random event has the same probability of success. And we're throwing 10 darts one at a time. So it says, find the probability that Slim hits the bullseye exactly 6 times out of the 10 darts. So this is what we call a binomial random variable. That is, how many times Slim is going to hit a bullseye. So we're going to let X be our random variable, and that is the number of bullseyes out of 10. And so what we're doing is we're asking this probability, what is the probability that our random variable will be exactly 6? And so this is a binomial problem here. This is a binomial probability problem. So what I'm going to do is I'm going to go straight to the TI-84, because if you are yeah, thank you, Chrissy. So what we're going to do here, if you are a stat student, you would be using your TI-84. And the command that you would use for a binomial probability is found in stat, or no, it's actually in second function distribution. So if you do second function vars or second function distribution, and you scroll down, you will find a command, binomial PDF. There it is right there. And then what it's going to ask you for is how many trials, right? So in this case, our number of trials is 10. The probability of success for any one of them is 0.8. So that's what we call our probability of success. And then the random variable value is 6 in this case. So we're going to say that we are doing 10 throws, or Slim is doing 10 throws. His probability of success on any one of them is 0.8. And we want to know what's the probability that he hits exactly 6. And so we can paste that command in, execute the command, and then we get an answer of 0.088. All right. Now, I do want to show you, take me back to full screen there, Christina, because I'm going to pull up another file that I want to show the student who asked about this one. And this is the formula sheet that you would be using on your AP stats, because on that formula sheet, okay, and then you can take me back to full screen. There we go. Thank you. So what you'll see here is for binomial random variables. You will see this on your formula sheet. It shows you this. This is what your binom PDF that I just executed over here, that's what it's actually calculating. So what it did on this problem, we said there were 10 trials. We wanted to know the chance that there was going to be 6 successes. That P was the 0.8, the probability that Slim hits a bullseye on any one of them. And that would be raised to the 6th power, because we're talking about there being 6 bullseyes. Now, his probability of failure is 1 minus P, or in this case, 0.2. And N minus X would mean he had 4 failures. That'd be 10 minus 6, or 4. And so that's the calculation. Now, even though you're using your TI-84 to do the calculation, you still need to be knowledgeable on that formula, because in multiple choice questions, they will ask you to show or to pick the right formula for a particular scenario. And so that would be the formula. Now, what is this 10 right here? This is how many different ways. That's what we would say is 10 combination 6. That's how many ways Slim can throw 10, but yet make 6. Because there are many, many combinations, many ways that it could actually occur. He could hit the first 6 and then miss the last 4, or many, probably thousands of calculations or thousands of combinations. But so you have to multiply that by those two right there. So that was the answer there. So let's go back and look at the next one. It says, find the probability that he hits the bullseye at least 4 times. So that would be the probability that he gets greater than or equal to 4 successes. Now, what we're going to do here is we have to calculate the probability. If we were to calculate this, we'd have to find the probability that he hit 4 bullseyes, add to that the probability that he hit 5, plus the probability that he hit 6, all the way up to the probability of him hitting 10. And we'd have to add them all together. So instead of doing that, what we're going to do is we're going to use a binom CDF. But the binom CDF on the TI-84 requires us to use the complement of this. So I am going to find the probability that he hits less than or equal to 3. So think about it this way. This is the best way to think about this. Think of all the ways that Amarillo Slim could actually throw 10 darts. He might hit none. He might hit 1 bullseye, 2, 3, 4, all the way up to 10. Maybe he hits all 10 bullseyes. And each one of those outcomes of 10 throws has its own probability that you could calculate with binom PDF. All right, so what we're asking, though, is what is the probability? Oh, and by the way, all of those probabilities would have to add up to the number 1. All of them would. Now, if we want to find the probability that he hits it at least 4 times, we would have to add up all of these probabilities. I'd have to run binom PDF 7 times for 4 all the way through 10 and add them up. But instead, what I'm going to do is I'm going to find out the probability that he hits 0 to 3 and take that away from the number 1, and that would leave me the probability that he's 4 through 10. So I'm going to do this 1 minus the probability that he hits 3 or less, which that right there is what we call the binom cumulative distribution, or CDF function. So if we come back over to the TI-84, we're going to hit stat, or again, we're going to have to do second function distribution and choose binom CDF. And we would have 10 trials. Probability of any one of them being successful is 0.8, not 0.08, but that is 0.80. And we're talking about 3 or less. We paste, we run that. Now I'm going to do 1 minus that value, and I get 0.999. So the probability that he hits the bullseye at least 4 times is very high, almost certain, 0.999. Makes sense, really, if you think about it. If he's that good and he's hitting 80% bullseye, the probability that he hits at least 4 out of 10 is going to be very high, and that's reflected in this. Now, compute the mean number of bullseyes in 10 throws. Well, since this is a binomial random variable, the mean is going to be equal to his probability times the number of trials, n times p. So he's throwing it 10 times. 0.8 is the probability of success on any one of them. So that is 8. That means that over many times that we observe Slim throwing 10 darts, on average, he's going to hit 8 bullseyes out of 10 after many, many different observations. All right, that is that for that question. I'm going to go down to the next one, which is a calculus question. And then you can see, I think I've got an algebra 2 coming up. I am going to check to see if anything came in through email. And nothing has come in. So we're going to continue on. So this is a calculus problem here from unit 5, I believe. So it says find the intervals where the function is increasing or decreasing, excuse me, and find all relative extremes. So what we have to do is we have to take the first derivative of this function. And to do that, we're going to have to use the product rule. The product rule says if I have the product of two functions of x, then here is the formula for that. If you're taking the derivative of two functions that are multiplied, we call those generically f times g. Then I'm going to take the derivative of the first times the second plus the first times the derivative of the second. All right, so let's do that. The derivative of the first function would be just number 1. X minus 2, the derivative of that is 1 times e to the x, plus then the first function x minus 2 times the derivative of the second. And the derivative of e to the x is just e to the x. So that is my my derivative function right there. What I'm going to do then is set that equal to 0, because if I want to know where the function's increasing or decreasing, I need to know where the function changes directions or where it could possibly change directions. And those locations are called critical values. So when I set the derivative equal to 0 and solve it, a couple of ways we could do this. Let's go ahead and distribute the e to the x there. So that would be x e to the x minus 2 e to the x equals 0. And this is a nonlinear function, so I'm going to solve it by factoring. I'm going to pull out the GCF of e to the x. But before we do that, let's go ahead and combine these two terms. Those are like terms. So that would give me negative 1 e to the x plus x e to the x. We'll factor out the common factor of e to the x. That would give me negative 1 plus x. And then once we factor, we set each of the factors equal to 0. Well, it doesn't take long in this section of AP Calc to realize that whenever you have this common factor e to the x and you set that equal to 0, there are no solutions to this right here. If you took the natural log on both sides to solve for x, you can't take the natural log of 0. So no solutions arise from that part or from that factor of the derivative. However, we can say negative 1 plus x is equal to 0. So therefore, x equals 1. That is a critical value. What we're going to do to answer our question is, first of all, I'm going to move these guys out of the way. And we'll answer that next. But what I'm going to do is I'm going to draw an x-axis and plot my critical value of 1. And then I'm going to take a point to the left of 1, which I'll use as 0 as my point to the left of 1, and then I'll use the number 2, which is to the right of 1. These two values that I'm picking right here are representing all values to the right of 1, x equals 2 is, and 0 is representing all the values on the x-axis to the left of 1. Now what I want to do is find out what's the sign of f prime of x for these two test points. Well, when x is 0, if I come back up here to my factored form, when x is 0, this will be positive. And when x is 0, that's going to be a negative 1. Positive times negative gives me a negative. When I stick a 2 in, e to the second power would be positive, but negative 1 plus 2 is positive. Now, what does that tell me? That tells me that f of x, since the derivative was negative, had to be decreasing. And since the derivative was positive, that tells me to the right of 1, f of x would be increasing. So that means I can answer the question, both of these questions here. Where is the function increasing? Well, I would say that f of x is increasing over the interval negative infinity to 1, 1 to infinity. And the reason for that, if I had to justify it, usually they will on a free response question ask you to justify it, because f prime of x is greater than 0. So wherever my derivative is positive, then I know that my function will be increasing. And then we can say that f of x is decreasing from negative infinity to 1. And that's because in that interval, f prime of x is going to be less than 0. And there we go. That also means that I do have a relative minimum at x equals 1. And that was the other question, right? Find all relative extremes. And so I can say that f of x has a relative minimum at x equals 1. And that is because f prime of x changes from negative to positive, like that. And it's always a good idea, students, to, when you do practice problems in AP Calc, to go ahead, when you're done, graph the equation and make sure that your analysis makes sense from a graphing perspective. So I'm going to go ahead and plot in Desmos x minus 2 times e raised to the x power and see if that indeed is what is true. So if you look here, you can see there is a relative minimum at x equals 1, and the function was indeed decreasing. And then once it got past 1, it started to increase. All right, so that's what calculus does for us. It's one of the things that it does is it allows us to do this analysis without the benefit of technology, right? When you were in Algebra 2, you just did not have the skills or the abilities to answer these questions about when does a function change directions. Other than just graphing it and looking at it, you wouldn't know. But calculus does allow us to do that. All right, we're going to continue on. So this is an Algebra 2 equation problem here. It says it gives us a polynomial division problem, and it wants us to use synthetic division to do the division. And I don't think that's going to be too difficult here. So if we're going to do synthetic division, what we're going to do is we're going to divide by the 0 of this binomial. Since this is our divisor, we're dividing by x minus 8. If you set that equal to 0, you get an 8. So we are going to be dividing by 8. In fact, I don't recommend doing synthetic division unless it is a binomial with a coefficient of 1 in front. If it's something other than a binomial with a 1x with a 1 in front of that x term right there, I would use long division. Okay, so anyways, what do we do? To divide, we're going to pull the coefficients off of our quotient here. So we have an 8. We have a negative 64 in front of the x to the third. Notice, though, that we are missing an x squared. So that would be that there's a 0x squared. So we have to fill in that missing term with a 0. Then there's a 3. And then there's a negative 28. Well, we start the synthetic division process by bringing down this first coefficient straight down. And then we proceed to multiply. We do 8 times 8, and we put the result of that multiplication in the next space in this blank row right here. Then we add right here. So negative 64 plus 64 ends up being 0. 8 times 0, we put the answer 0. We add, we get 0. 8 times 0 is again 0. We add, we get 3. And then 8 times 3 is 24. And then we add, and we get a negative 4. And this is our remainder right here. So to write the answer, these coefficients, these are the coefficients to the answer, where this one will be the constant 3. This would be my x term. That would be my x squared coefficient. That would make an x cubed. So this is 8x cubed plus 3. That remainder of negative 4 means I would tack on another term and do minus 4 over this x minus 8 divisor right there. So the final answer here is 8x cubed plus 3 minus 4 over x minus 8. And that is our answer to that one. Okay. Next, let's move on. This was in an AP pre-calc. I think what I'm going to do is I want to move on to do some SAT questions that I needed to cover here. This comes from one of the practice tests, I believe, maybe practice test 10 in Blue Book. And I didn't mention it earlier when I was talking about the SAT, but Blue Book is scheduled to be releasing more practice tests in Blue Book. College Board is supposed to be releasing those sometime soon. We were hoping they'd be released before the December test, but it doesn't look like that's going to happen. So I suspect sometime after December, and then in plenty of time, I'm hoping before the March test, they will release maybe 3 or 4 new practice tests in the Blue Book app. But here is a question that says that a circle has a center G, points M and N lie on the circle, line segments MH and NH are tangent to the circle at those points M and N. So we're going to try our best to draw this picture here. So there's our circle. We'll label the center G, and there's points M and N. So I'm just going to, they don't tell us where they are relative to one another. So we'll just start off by putting them at those 2 random spots. There are 2 line segments, MH and NH, that are tangent to the circle at points M and N. So if I were to draw a tangent line, that means it's a line that's going to nick the circle at that point on the circle. So it's going to look like that. So this intersection has to be point H right there. I know a lot of students struggle with making this picture, right? But this really, in order to make sense of this problem, this is crucial. So you have to know what a tangent to a circle looks like. And there you go. Now, they do tell us that the radius of the circle is 168 and that the perimeter of quadrilateral GMHN, that would be GMHN. So I would have to draw in those 2 radiuses. And those would each be 168 millimeters. So there's my picture. Their question, though, is what's the distance between G and H right here? Well, that's what we're trying to find. The secret to this problem is back in geometry, we told you that if you have a point of tangency on a circle, where there's a tangent line that hits the circle at that one point, and you draw a radius out to that circle, to that point of tangency, you will make a right angle between the radius and that line of tangency right there. So these, no matter how good or bad your drawing is, those are supposed to be right angles. So what I'm going to do is use the Pythagorean theorem to get this length GH. If the perimeter is 3856, what I'm going to do in Desmos is I'm going to take 3856 and take away 168 2 times. And that'll leave me then 3520, and I'll divide that by 2 to split it equally between MH and NH. Those are 1760. You know, the other thing too from geometry, that no matter how good or bad your drawing is, you are supposed to know from geometry that if you have 2 tangent lines that do intersect outside of the circle, the distance from the intersection point to the 2 points of tangency is equidistant. So those have to be the same value right there. Now I can use the Pythagorean theorem. So that distance GH squared has to be equal to 168 squared plus 1760 squared. So what I'll do is do this as one calculation. I'm going to do square root of 168 squared plus 1760 squared, and I get 1768. I think this was multiple choice. I'm pretty sure this was a multiple choice question, but the answer ends up being 1,768 millimeters. That's what that was. All right. I've got a few more SAT questions that I want to cover. Just checking to see if we've got any questions that did come in. And none. Let's keep going. I think I've got time to finish these 2 questions here. And you can see this question number was 21. This is number 20. These are 22. So I'm quite certain that these problems all come from module 2 of a hard module. So these are not intended in any way to be easy questions at all. So this one says that in the XY plane, a circle C has coordinates HK, points A and B lie on the circle, and point A has those coordinates, and ACB is a right angle. What's the length of AB? When you read that problem, you're probably like, I have no idea what they're even talking about. What are all of these measurements? The only way you have a chance right here is on your scratch paper is I would draw a pretty big circle to give yourself plenty of room. It's probably not a bad strategy, being question 20, to maybe skip this question because it does look like it's going to take some time. So you might want to, if you see that your time is dwindling down, to look at questions 21 and 22 to see if those look like they might be easier or faster than this one. But let's solve it. Now, I am going to go ahead and put this into the XY coordinate system. So this right here is H, and the Y value is K for the center. Now, when I coach my students about drawing sketches of graphs, when you are plotting points, if you're going to bother making a graph and you've got ordered pairs, you want to be plotting those coordinates on the X and Y axis so you can make spatial comparisons along both axes. You'll see how important that's going to be, I think, in this problem. So there is my center H comma K. Again, I'm just going to put point A up here. It says that its X coordinates are H plus 1. Okay, so that would mean I'm going to come down here and call that H plus 1. And then this one is K plus root 102. All right, and there's another point B, but we don't know where that lies. So they didn't give us coordinates, so we'll put that there. Now they're talking about angle ACB. So the center is point C. So angle ACB. Okay, so I think that's a pretty good spot for B. Right, this is they're saying angle ACB is a right angle, and they want the length of AB. So okay, so now at least I have a little bit better idea of what they want me to find. That is the distance for us to find. Now, how am I going to do that? Well, what can we do to find that? Now, the thing that really is crucial here is this triangle that we just drew, that's a right triangle. We have to really understand that this is a 45, 45, 90 triangle, right? Because it's an isosceles triangle. These 2 legs of the right triangle are radii of the circle, so they have to be the same length. Therefore, I need to just find the length of AC, and I could multiply it by the square root of 2 to get the length of AB. So here's what I'm going to do. I am going to make a right triangle with AC being the hypotenuse. Look at this. Okay, because I now know that this vertical distance right here is the square root of 102, right? If that's K plus 102, this distance between those 2 Y coordinates is root 102. Same thing over here. This distance between H and H plus 1 is 1. So therefore, the length of AC is going to be the square root of root 102 squared plus 1 squared. Well, what is that? Root 102 squared is 102. So this would be root 102 plus 1. It'd be root 103. That's the length of AC. So now if you know the leg of the 45, 45, 90 is root 103, then AB, which is the hypotenuse of that 45, 45, 90 triangle, is root 103 times root 2, right? This is one of the things that you have to know about special right triangles on the 45, 45, 90, that the hypotenuse is root 2 times the leg. So this answer should be root 206. Now, I don't think I've got the multiple choice answers on this one either, but this is, I'm quite certain that this was a multiple choice problem, and that is going to be the measurement for AB right there. Super challenging problem for sure, but that is how you work it. Let's go to the last one, and I think this is going to be it for tonight, and then we will call it quits. This, at least I got the answer choices on this one. It says here that the function f is defined by ax squared plus bx plus c, where a, b, and c are constants. The graph in the xy plane passes through those 2 points. Those happen to be x-intercepts. If a is an integer greater than 1, which of the following could be the value of a plus b? Well, this is a challenging quadratic problem. So the first thing that you recognize is this equation is a quadratic, and they told me that 7 and -3 are the x-intercepts. And they did tell me that a is greater than 1, so it will definitely be a parabola that opens up. So it's something that looks like this. Now, when you're given 2 x-intercepts for a quadratic, the midpoint between those 2 x-intercepts is going to be the x-coordinate of your vertex. So if you add 7 and -3, you get 4, and then divide that by 2, that means that the middle is 2. That may be helpful, it may not be helpful, but for sure that vertex is going to be at x equals 2. Now, which, if an a is an integer greater than 1, which of the following could be the value of a plus b? Well, since they gave me 2 x-intercepts, what I'm going to do is I'm going to write a different equation for the same parabola using the x-intercepts. Because if the x-intercepts are 7 and -3, it means that in factored form, the parabola's equation has to look like this. I do have the same value of a, right? That's the one common thing between all 3 forms of a quadratic. The a coefficient will be identical. So what I'm going to do now is I'm going to multiply x minus 7 times x plus 3 and get x squared minus 4x minus 21, and then distribute the a. And so that would be ax squared minus 4ax minus 21a. And now, what would a plus b be equal to? Well, a is a. Okay, in other words, what they're talking about when they say the value of a plus b, they're talking about the coefficients in standard form. Well, what I did is I started in factored form and I converted it into standard form so that this a is a. Okay, so a plus b would be a, but b, what they're calling the coefficient b right here, is -4a. So a plus -4a is a plus b, which happens to be -3a. So if a is an integer greater than 1, which of the following could be the value of a plus b? Well, if I try these answer choices, right, these are all answer choices for a plus b, and I've just determined that a plus b is -3a. Could it be equal to -6? Well, if I did, that would mean a is 2, and that meets the criteria of being an integer greater than 1. So I think that's going to be my answer. Let's see if we could exclude the other choices. Is it possible that our a plus b, which is -3a, could it be equal to a -3? Well, if it were, A would be equal to 1, and that doesn't meet the criteria of being greater than 1. So that's not going to work. Could it be equal to 4? Could negative 3a be equal to 4? No, because it gives me negative 4/3. So it's neither an integer nor positive or greater than 1. So that's no good. And in a similar fashion, 5's not going to work. So if you take negative 3a and set it equal to 5, a would be a negative 5/3. So indeed, negative 6 is going to be my answer. Well, students, that is going to be it for tonight. I will be back next week, and that's going to be the 7th of December, and I'll be here at 8 o'clock. I do have a special topic that I will be posting also here on the YouTube channel, so you'll know what that topic is going to be up front at before we start. I'll do about 15 minutes on that topic. I think it's going to be related probably to, I'm not sure what, ACT maybe, because we got an ACT test coming up on December 13th. And then after that, I will take your homework questions. Okay, everybody, I hope you have a great week. I hope you had a great Thanksgiving weekend, and I will see everybody back here next Sunday. Thanks.